Good morning, dear students. My name is Ferhan Mazher, and today is 6th of May 2022. Right now, I am with the 11th Cambridge class, and the subject we are studying is Physics 5054. It's Cambridge O Levels Physics, and the code of the subject is 5054. Today, we have set our hearts to solve ATP paper, and we have selected October November 2013 4-2 paper. This paper 4 or the ATP paper belongs from the zone 2 or the variant 2. So let's start today's paper, and here is the paper. Okay. So 2013 October November 4-2, 1 hour is allowed. The first question coming up on your screen. A student investigates how a magnetic force varies with the distance. A bar magnet is attracted to the iron base of a clamp stand as shown in the figure 1.1. A Newton meter is attached to the magnet. So here you have a magnet, uh, here you have a Newton meter, and it is attached, this magnet is attached with this iron base. So by applying the force here, we will try to separate this magnet from this iron base because they are attracting each other. So here on the Newton meter, that force will be shown, that how much force is applied. The students pull the Newton meter vertically upwards and measure the force F required to pull the magnet off the iron base. Explain why it is difficult to measure the F accurately. You see, there is, because in his wording, a student investigator. So it looks like that a single student is working. So it's difficult for a single student, for one student to pull this Newton meter, and when this magnet is pulled off from this iron base, to note what is the reading on the Newton meter. So a single student cannot do this, both these things together. He pulls the Newton meter and he notes what is the reading given on the Newton meter. So it's quite difficult for a single student to do this. Another thing is that when you are applying force, and obviously the reading on the Newton meter is increasing, you increase the force. The moment this magnet will be separated from the iron base, the reading on the Newton meter will go down. So that is another problem, because once you reach that force on which this will separate, in a moment that reading will go down because the magnet will separate and the reading on the Newton meter will decrease. So these are the two basic problems. Okay, let us show you what I have written, and then we will see. When the magnet pulls off the iron base, reading on the Newton meter decreases. For one student to pull and note the reading is difficult. So these are the two answers which I have written. So let's check from the marking what the marking scheme has to say. The marking scheme says measure a force just before it jumps, and reading meter and pulling magnet at the same time. Force varies, is not constant. So you can write any sentence here. So okay. So we are going to the next question. The second part, describe a method the student can use to measure F more accurately. Okay, so there can be different methods. For example, the two students can work together. One will pull the Newton meter, and the other one will note down the reading on the Newton meter. Another good method can be that you take a camera and you start filming the Newton meter. So whatever will be the maximum force shown during this process, or so if you are recording it, then it is quite easy to note down what is the reading when the magnet is pulled off the iron base. So let me show you my answer, and then we'll see. Two students should work on this. One pulls Newton meter, and the other one, here should be the other one, note the reading on the Newton meter. So let me check the marking scheme. Sensible suggestion, for example, use of the two people explain, pull slowly, repeat, video, Newton meter. You can write any answer, okay? Here you have to give a suggestion, okay? Okay. So figure 1.2 shows the maximum reading on the Newton meter as the magnet is pulled off the base. Okay. So record the force F shown on the Newton meter. So what is this force? This is between 5 and 6. So it's 5.5. So 5.5 Newton is our answer. 5.5 Newton and plus minus 0.1. So 5.5 is the right answer, sir. Okay. So the next question, he says the student places one sheet of paper between the magnet and the iron base and measures the force F to pull the magnet off the base. He repeats the experiment each time, increasing the number n of the sheets of the paper. The results obtained are recorded in the figure 1.3. So it is 5.5 Newton. So note down here 5.5 Newton. On the figure 1, add your value of the B. Okay, right here 1.5. And let me tell you what they are saying. So between the magnet and the iron base, here there is no paper between the magnet and the iron base, and the force required is 5.5 Newton. Then put a paper between them, between the magnet and the iron base. Still the magnet will attract the iron base. Then put 2, then put 3 papers, then put 4 papers, then put 5 papers, and note down that how much force is required to pull off the magnet from the iron base or off the iron base. So here write 5.5. And then he says on the figure 1.4, plot a graph of Fn on the y-axis. The force will be on the y-axis. And the n, the number of papers, on the x-axis. Start your axis from the origin. Draw a smooth curve of the best fit. So it's a 4-mark question. So this is that graph which we have to draw. So let me show you my solution. Here write 5.5 Newton, and this is the x-axis, 0 paper, 1 paper, 2, 3 paper, 4 paper, 5 paper. This is the force which is required to pull the magnet off the iron base. And here you see what you have to do. First of all, you have to label the axis. This is number of papers, n, and this is the force which is noted down on the Newton meter. The force required to separate the force required to separate the magnet from the iron bar. So so we will put these points 0, 5.5. You can see I put a dot here. 1, 3.5, 1, 1, 3.5. Then you have 2, 2.5, 2, 2.5. And then you have 1, 3, 1.5, 3, 1.5. Then you have 4, 1, 4, 1. And then you have 5, 0.5. 5, 0.5 is this. Then you have to draw a smooth curve. So I have drawn it. This point is left little above this smooth curve. So this is how you will do this. So let me show you. What does he says? Okay. Okay. So our answer is right. We are able. Okay. The next part is describe how the F varies with the N. Okay. From the graph. So you see this graph here. So their question is, as you can see from this graph, as the N is increasing, the value of the F is decreasing. So that's a simple relationship between them. Another thing which you might think that this is the graph looks like the graph of inversely proportional. So to rule out that, I have done this calculation. If two quantities are inversely proportional to each other, their product remains constant. If two quantities are inversely proportional to each other, their product remains constant. So we have to check that if the product of the N and the F remains constant or not. So here I have taken 2 points. For example, at 1 you have 3.5 Newton. So multiply them, you get 3.5. So at 3 pages, the force required is 1.5. So multiply them, you get 4.5. You see the product of N and F is not constant. So F and N, they are not inversely proportional to each other. So don't use the word inversely proportional. If two quantities are inversely proportional, then their product remains constant. So you can say that as N increases, F decreases. Simple. Okay, so the next question, the Newton meter shown in the figure 1.2 is not suitable for measuring F when there are more than 5 sheets of paper. So just why? You see, when there are more than 5 sheets of paper, the force required is less than 1 Newton. At 5, it's 0.5 Newton. So when the sheets will be more than 5 Newton, it will be less than 1 Newton. The Newton meter which you are using, if you look at that diagram, the Newton meter which you are using, its least count is 1 Newton. Its least count is 1. Look, 0, 1, 2. So the least count is 1 Newton. It cannot measure anything which is any force which is less than 1 Newton. So that is the reason. So let me tell you. Let me show you my answer. And I hope you understand why we cannot use this Newton. Smallest reading Newton meter can measure is 1 Newton. The Newton meter they have shown us is smallest reading it can measure is 1 Newton. It cannot measure any force less than 1 Newton. Its least count is 1 Newton. So for n equals to 5, force is less than 1 Newton. So you cannot measure force required for when you put more than 5 sheets of paper. Okay, so I hope you understand. Let me show you the marking scheme. Here you see that's the relationship. Then the Newton meter is not sensitive enough, scale too big, no changes, same reading force is too small. For this meter to, okay, for this meter rule, it's not possible. Okay. Oh, hopefully you understand. Okay, so let's go to the next question. The next part. The student repeats the experiment using paper of a different thickness. His new value for the F when n is equals to 1 is 3 Newton. State which paper is thicker. Give a reason for this. When we use one paper in the first situation, the force required was 3.5. And in this second situation, when you have used one paper between the magnet and the iron base, the force required to separate them is 3 Newton. So now the force is less. It means this paper, before the force required was larger. For one paper, the force required was 3.5 Newton. But this time the force required is only 3 Newton. It means that this paper is thicker. That's why the force required is less. Thicker the paper, less is the force required to separate the magnet and the iron. So I think the second paper is thicker because force required is less than the force required in the first with the first paper. Okay, the next question is, this says explain. Let me show you the marking scheme. New paper, second thicker as force smaller, or reverse argument, paper that gives 3 Newton force. Okay, so our answer is right, sir. Okay, then their question is explain how using very thin paper improves the experiment. You see, by using a thinner paper and more values of the force will be noted down when you use thin paper. So by using the thin paper, more values of F can be obtained. More values of the F can be obtained. Okay. More sensitive, more readings, larger values for the F. So the larger, to measure the larger value is little easier. Smaller values are difficult to measure. More and larger. Okay. So what's the next thing? Very thin sheet may be made from aluminum foil. State and explain whether the aluminum foil is a suitable material for this experiment or not. Like the paper, the aluminum foil is non-magnetic material, so it can be used. Yeah, it can be used. So aluminum foil is non-magnetic, so it can be used. So that is our answer. Yes, aluminum is non-magnetic. Okay, so we are going to the next question. The next question is question number 2. A student investigates the reflection of the light. The student has available a pin board, a sheet of plain paper, a plain mirror, optical pins, a pencil, ruler and protractor. Describe how the student uses the apparatus to verify that the angles of incidence and the reflection are equal. Include a clear labeled diagram in your answer, and it's a 4-mark question. Okay, so very simple. Let me go to, okay, so here we go. So what you will do, you will take a white paper, fix it on a drawing board, and draw line AB and mark its midpoint M. Then draw a normal on the midpoint. Normal is perpendicular to the AB with dotted line. Then draw a line CM, and which makes an acute angle, and that line is on the left side of the normal. On that line, put two pins P1 and P2 5 centimeter apart. Put a plane mirror with its reflecting face towards this C and N, and on the line AB. And then look into the mirror on the right side of the normal, from the right side of the normal. And try to look for the image of the P1 and the P2. So when you are able to see the image of the P1 and the P2 in the mirror, and you are on the right side of the normal, take two more optical pins, pin 3 and pin 4, and put them in such a way that the pin 3 and the image of the pin 1 and pin 2 are aligned. And then put the pin 4 such a way that the pin 4, pin 3, and the image of the pin 2 and the pin 1, they are aligned. Then mark the position of the pin 4 and pin 3 on the paper, and then remove everything. Join P4 and P3 with the M, and then with the help of the protractor, measure the angle of incidence between the angle of incidence, which will be between the normal and the incident ray, and measure the angle of reflection, which will be between the reflected ray and the normal. And you will observe they will be equal. Then you can do the same procedure again, but this time increase the angle of incidence a little bit, and you will get again and again the angle of incidence and reflection and angle of reflection, and they will be equal. So let me read you. I hope you have understood what I have written. I just read for you. Okay, so let me read it. Fix a white paper on a pin board or drawing board, you can say. Draw a line AB, mark it midpoint M, draw normal MN at the point M onto AB. Draw a CM line making acute angle with the normal. Put two pins P1 and P2 5 centimeter apart on the CM line. Put mirror on the AB and look into the mirror from the right side of the normal, and put the pin P3 and the P4 such that the P3 and the P4 and the image of the P1 and the P2 are aligned. Mark the position of the pin 3 and the pin 4. Join the pin 3 and pin 4 with the M. Measure the angle of incidence and the angle of reflection. They will be equal, and you will note that they will be equal. Repeat by changing the angle of incidence. Okay, and angle of incidence, remember, you can also write here, the angle of incidence is the angle between the incident ray and the normal, and the angle of reflection is between the reflected ray and the normal. Okay, so hopefully you understand, and let me show you for a second that written answer. So you can pause the video and you can read it yourself, and this is that diagram. Okay, so the student carries out the experiment carefully. Describe one practical technique that improves the accuracy of the experiment. The lines you draw, they should be very thin. The pins should be aligned from their bottom, not from their heads. So I hope you can understand this letter. Let us see the marking scheme. Okay, here we have. Is a diagram showing paper and the plane mirror plus the incident and reflected ray, or 4 roughly correct pins, 2 pins placed on incident ray pins, or image of the pins viewed in through the mirror, line drawn, and the angles incident and angle are measured to the normal. And sensible selection, for example, view the bottom of the pins. We have given this pin, pins vertical, pins apart, for example, greater than 5 centimeter. Repeat for different angles. Repeat experiment. Sharp pencil. We also have given this thing. Okay, so we are going to the next question. That is question number 3. He says, A student uses a lemon to make a simple electric cell. He inserts a copper strip and an iron nail into the lemon as shown in the figure 3.1. So this is a true thing. You take a lemon and two different metals. This is copper and this is nail, and this will act like a cell automatically. The student connects a center 0 voltmeter between the copper strip and iron nail to measure the EMF produced by the lemon. The figure 3 point shows the voltmeter with the reading obtained. The record the EMF shown on the voltmeter is 0. This reading is, how much is this reading? Let's check. This reading is, sir, how much? The reading is 0.9 volt to the left side. Okay. So we have to note down that the reading is 0.9 volt. So the reading is how much? 0.9 volt. Okay. Then the question is suggest how the connecting leads from the voltmeter. How the connecting leads from the voltmeter can be securely attached to the strips and to the nail. To attach them with the strip and the nail, you can use the crocodile clips and make sure that the coil is tightly wrapped with the connection of the crocodile. Wrap the wire tightly with the crocodile. Use of the crocodile clip. And then the question state what happens if the connections to the voltmeter are reversed. If you reverse the connections with the voltmeter, the reading will still be 0.9 volt, but this time and the voltmeter was deflecting 0.9 volt towards the left. Now it will deflect to the right, but the reading will still be the same 0.9 volt, but it will deflect to the opposite direction. Deflection of the pointer will be in the opposite direction and the deflection will be same, 0.9 volt. He says, suggest one reason why the lemons are not used to power the simple electronic equipment such as digital watches. We do not use the lemons for batteries because they run down very quickly and they are not reliable. Okay. So hopefully you understand this. Okay, we are done with this. The student connects lemon cells in series and measures the total EMF with the voltmeter. State the total EMF that you would expect. So if you have 3 lemon cells, each cell is producing 0.9 volt, you connect them in series, so their EMF will be added up. So 0.9 plus 0.9 plus 0.9, it will be 2.7 volt. So it will be 2.7 volts. So then he says on the figure 3.3, draw the connections that the student uses. So when you connect them in series, the nail should be connected with this, and this nail should be connected with this. From this nail, I should take a connection, and from this iron strip, I should take a copper strip, I should take a connection. So let me show you. So we are done with this, okay, and 2.7 volt, okay, and this is that connection. You can see the nail is connected with the copper, then again the nail is connected with the copper. From nail, I've taken out a connection, and from the copper, I have taken out the connection, and then we have connected them with the voltmeter. Okay, so I hope you understand this. So then he says, the student connects 3 lemon cells in parallel and measures the total EMF with the voltmeter. State the total EMF that you would expect. You see, when you connect them in parallel, their EMF do not add up. So because they are identical, so individual has 0.9 volt EMF. So the EMF of the combination will be also 0.9 volt. So because you're connecting them in parallel. So when you connect them in parallel, the copper connected with the copper, and you take a connection. Iron nail, they will be connected. Then take out the connection and you connect them with the voltmeter. So let me show you my answer. So here we go. I hope you can see on your screen the copper and copper and copper. They connected with each other. Iron nail connected with each other. And from there you connect it with the voltmeter. The reading on the voltmeter will remain 0.9 volt because they are connected in parallel to each other. So the EMF will not add up. So this was the question number 3. Let's have a look at the marking scheme. And my dear students, I have already checked the marking scheme, and you can pause the video and you can take your time and read this marking scheme. And remember one thing, when I solve a paper, there's a chance that I might make a mistake in some calculation, in some procedure. I might make a mistake. I try to avoid the mistake. Normally I don't make mistake, but there are chances that this is possible. So it should be your habit that whenever you solve a paper, always, whether I am giving you the answers, your teacher is giving you the answers, your mentor, your instructor, your tutor, whoever is giving you the answer, even a red spot is giving the answer, read from the mark, compare the answer with the marking scheme. It's a very important, and the key to success is this in the Cambridge exam. Okay, so I hope you have read the marking scheme. I have already checked my answers with the marking scheme. So we are going to the next question. He says a student is given a bag of 10 similar marbles. The student uses a 30-centimeter ruler to determine the average diameter of the marble. Describe how the student obtains an accurate value. Include a label diagram showing how and any additional apparatus is used. So this one is 3 marks, and then we have a 1 mark and 1 mark question. Okay, so first of all, this 3 marks question. So what we will do, we have 10 marbles, so we will place them beside a wall on the floor, and we'll put two wooden blocks. We will use two wooden blocks, and I will put 10 marbles between the wooden blocks. They all should be touching each other, and then I will put a scale in front of the wooden blocks, and I will measure what is the distance between the wooden blocks from each other. And whatever will be that distance, divide it with the 10, and you will get the diameter of one marble. And it will be very accurate because it's an average of 10 diameters. Okay, a student is given a bag of 10 similar marbles. Okay, so this is that diagram. You can see I have used a wooden block, and I have put 10 marbles. They are touching each other, and I put a scale on the floor and measure what is the distance between A and B. So between the blocks, I mean. So and then divide this distance with the 10, and that will give you the average diameter of the marble. Okay. So they put 10 marbles between two wooden blocks beside a wall on the floor by using ruler, measure distance between the blocks, divide this distance with the 10 to calculate the diameter of the one marble. I hope you understand this. I hope that you understand this experiment, what I'm saying. Okay, he says the student then measures the diameter. That's the next question. Let me show you. Okay. Then he says the student then measures the diameter of one marble accurately using a micrometer. The scale of the micrometer is shown in the figure 4.1. State the reading shown on the micrometer. Okay, you can see this is 9, 10, 11, 12, 13, 14, 15, 16, and this is 16.5. So I will note down 16.5. And then I will check that on this circular scale, which line is coinciding with this horizontal line. So this is 30. So 16.5 plus 3, 16.5 plus 0.30, 30. So you will get the answer. So let me show you my answer. So here you can see 16.5 plus 0.30. So it will be 16.80. So the diameter is 16.80 millimeter. I forgot to write here the unit. It is millimeter. So write here millimeter. Okay. The last question is describe how the student checks that the marble is spherical. So you can measure the diameter of the marble from different positions on the from the surface of the marble. And if you find that from every position the diameter is same, if you measure the diameter of the marble from different position and you find that the marble's diameter from every location, every position is same, it means that the marble is sphere, is a perfect sphere. So measure the diameter of the marble from different locations on its surface, diameter will be constant. So if the diameter is constant, then it means that this is the thing. It's a perfect sphere. So measure all the 10. Okay, so you can pause the video and read this marking scheme carefully. Okay. So you can pause the video pause the video and read this marking. So you can use the wording from here also. Okay. So my dear students, today we have completed October, November 2013 Physics 505442 paper. This was an ATP paper and we have completed it. I have tried my best to explain you the concepts involved. So if you think that this video is helpful to you and this video has helped you to solve this paper, please subscribe my channel. Also share the link of this video onto your WhatsApp, onto your Facebook accounts, onto your Twitter accounts. Also like this video. If you have any comment, please feel free to comment. And also share the link of this video with your junior students who will be doing who will be preparing the Cambridge exam next year. So it's a great blessing for me to teach you online and be helpful to so many people. So thank you very much, everyone, for taking out time and watching these videos and preparing yourself for Cambridge exams. So thank you very much once again. Have a good day. God bless you all.